Hi. So coming to this question, here we have two machines, machine M1 as well as machine M2. They can independently produce either product P or product Q, and the time taken by machines M1 and M2 in minutes to produce these products is given below. So to produce 1 unit of P, M1 takes 10 minutes whereas M2 takes 8 minutes. Similarly, to produce Q, M1 and M2 both take 6 minutes each. Okay. So based on this data that is given, a very simple table, we have to answer the following 5 questions. Let's look at the questions. First question, what is the maximum number of units that can be manufactured in a day? Now each machine works for 8 hours in a day. Fine. So the total number of hours is 8 into 60. That means 480 hours per day. That is what we have. Okay. Now we have to manufacture the maximum number of units in a day. So to manufacture maximum number of units, what we need to do is we need to minimize the amount of time taken to manufacture one unit. Hence what we will do is we will produce Q using both the machines, because Q takes the least time for both the machines to be produced. So machine 1, how many units of Q can machine 1 make? It will be 480 divided by 6, total 480 minutes, and each unit of Q takes 6 minutes. So the number of units that can be produced is 80 units. M1 can produce 80 units of Q in a day maximum. Same is the case for M2. M2 also can produce a maximum of 80 units of Q in a day. Hence the total number of units will be 80 plus 80, 160. The maximum number of units that can be produced in a day is 160. Okay, let's look at the next question. Now if M1 works at half of its normal efficiency, what is the maximum number of units produced if at least 1 unit of each must be produced? That means now instead of producing only Q, we need to produce at least 1 unit of P as well. So let's try to maximize the number of units first, and that would be done when we produce Q using both the machines, right? But the only problem now is the efficiency of M1 is half. Since the efficiency is half, time taken by M1 to produce both P and Q will become double. So time taken to produce P will become 20 minutes and for Q it will become 12 minutes. Now in this case, the maximum number of Q M1 can produce will be 480 divided by 12. This is 40 units of Q. And the maximum number of units M2 can produce is again of Q is 480 divided by 6, which is 80 units of Q. So we have a total of 120 units of Q here. But this is not the there is a catch here that we have to produce at least 1 unit of P as well now. So how can we produce 1 unit of P? See, to produce 1 unit of P, we need to have 8 minutes, right? So how can we give 8 minutes to produce P? What we can do is, instead of producing 80 units of Q here, let me subtract 2. That means let's manufacture 78 units of Q now. 78 units of Q now. So how many extra minutes did we get now? 6 into 2, 12 minutes. We have reduced the number of units of Q by 2. That means we have gotten an extra 12 minutes now. Using that 12 minutes, we can produce exactly 1 unit of P. 4 more minutes will be ideal, but we cannot do anything from those 4 minutes, right? We saved 12 minutes, utilized 8 minutes for manufacturing of P. The remaining 4 minutes will be idle. So we can manufacture 1 unit of P from here. So effectively we have 79 units being manufactured by M2 and 40 units being manufactured by M1. So total number of units, maximum units will become 119 now. Option D here. Okay. Let's look at the next question. What is the least number of machine hours required to produce 30 pieces of P and 25 pieces of Q respectively? Least number of hours Now it's not the least number of hours, it's least number of machine hours. Okay, so machine hours is basically how long the machines would be working, right? Independently, how long the machines, each of them, total number of hours each of them works. If we have to minimize the machine hours, what we need to do is we need to maximize the efficiency, right? So if you have to manufacture P, it would be best to get P manufactured by M2 because M2 takes the least amount of time of the both machines. So to produce 30 pieces of P, it will take 8 minutes per piece. So 240 minutes would be required by M1 to produce P. For Q, 25 pieces. Now Q can be produced by any of the machines M1 and M2. Both of them take 6 minutes. So this becomes 150 minutes. Let's say this is done by M2 here. Okay. Now the machine hours will be, total machine hours will be 390 minutes. 390 minutes converted to hours will be 390 divided by 60. That means 6 hours and 30 minutes. These are machine hours. This is the amount of time machines would be running. This is not the actual amount of time taken. Okay. So the answer here is option A. One machine is working for 240 minutes, the other would be working for 150 minutes. Hence the total minimum machine hours is 6 hours 30 minutes here. Fine. Let's look at the next question, question 4. Now here in this question we have if the number of units of P is to be 3 times the number of units of Q, what is the maximum idle time to maximize total units manufactured? Okay, so we have to calculate the maximum possible idle time if the number of units have to be maximized. Number of units have to be maximized given the condition that the number of units of P has to be 3 times the number of units of Q. So we have to produce a lot more of P as compared to Q. So here let's do one thing. Since we have to maximize P, that means we'll have to minimize the amount of time required to manufacture P. So let us manufacture or use M2 to produce only P here, right? So the number of units of P produced by M2 producing P, maximum units that can be produced is the total amount of time in a day for each machine is 480 minutes, and P takes 8 minutes to manufacture 1 unit. So the maximum number of units of P that M2 can produce is 60 units. Fine. Now this has to be at least thrice of the this has to be exactly thrice of the number of units of Q produced. That means M1 produces 20 units of Q at least. So the time required to produce 20 units of Q by M1 will be, M1 takes 6 minutes to produce Q. So 6 into 20, that is 120 minutes. 120 minutes. Fine. So if M1 produces Q for 120 minutes, it can make 20 units of Q. And if M2 makes only P, it will make 60 units during the whole day. Now still we have 480 minus 120, 360 minutes of Q remaining. 360 minutes of Q remaining. That means we can manufacture some more Q and P's. Fine. Now let's say the number of, sorry, not Q, M1, this is M1. 360 minutes of M1 are remaining. Now if let's say the number of units of Q produced is X and that of P produced is 3X here. Fine. This is being produced by M1. We can make some more units of P and Q. If X units extra of Q are produced, 3X extra units of P will have to be produced. Now to make X units extra of Q, only M1 is working, right? So it will take 6 minutes per unit. 6x more minutes will be required. And for P, this will be 3x into 10. that is 30x minutes will be required. So the total amount of time required will be 36x minutes. Now this 36x minutes should be less than or equal to 360 minutes, because we only have 360 minutes available of M1. That means x should be less than or equal to 10 over here. So if x is 10, we have to maximize the number of units. To maximize the number of units, x would be exactly 10. So now if x is exactly 10, that means the whole of 360 minutes will be utilized for M1 also. If the whole of 360 minutes is utilized, that means we have no idle time for either of the two machines. Hence the answer to this question is option A, 0 minutes. If we maximize the number of units produced, the idle time will be 0. Okay, fine. Now coming to the last question, which is question 5. If equal quantities of both are to be produced, then out of the 4 choices given below, the least efficient way would be. Out of these 4 ways given to us, we have to figure out which is the least efficient way. Okay. So here if you produce 48 units of each with 3-minute idle time. Okay. If you produce 64 units of each with 12 minutes idle time, and so on. So productivity, we have to basically figure out which of these 4 options have least productivity. And how can we figure that out? By simply comparing the number of units produced per amount of idle time. If the number of units produced per amount of idle time is high, that means the productivity is high. If the number of units produced per amount of idle time is low, that means the productivity is low. For 1 minute of idle time, if I produce more units, that means I am more efficient. If for 1 minute of idle time I produce lesser number of units, that means I am lesser efficient. So for option A, the productivity as we defined would be 48 by 3, which is 16 units per minute of idle time. So for every 1 minute of idle time, option A, 16 units can be produced. For option B, this becomes 64 divided by 12. So this will be, this goes by 4 16 times, this goes by 4 3 times. So this is 5.333 and so on. Okay. Option D, this is 71 by 9. This is almost 8. This is like 7.9 approximately. And here this is 53 by 10, which is 5.3 here. Okay. Now if you look at of all the 4 options, the least number of units being manufactured is here in option C. Hence the least efficient of all the 4 options is option C over here. Right? So that's it for this set. Thank you.